Okay, so audio. If you guys have seen my last video, basically probably over the 60 last videos that I posted, the 60 newest last videos that I posted, haven't had any audio. And it's crazy. I'm already at like 100 videos. But so around over 60 of my last newest videos haven't had any audio because one day I decided, okay, well, it's late. I still want to record, but I want to turn off my audio, my microphone, and I just never remembered to turn it back on. And I've been talking throughout all my other videos on everything that I was doing in terms of the exercises I was coding in. I was explaining everything that was going on and explaining just everything that was going on basically in detail, on a basic level, right? And I just never realized that I hadn't been recording my audio for my voice. So that really sucks because there was a lot of information that I was passing through all those videos. And yeah, so just in this video, we're just going to continue the exercise uh, 3.1. And just give me 1 second here because I need to pull up the website again. So if you guys have been following me for my last videos, the exercises that I've been doing have all been from this one website. Um, and we are at exercise 3.1 of all the way up to exercise 8.1, it seems like. Um, and yeah, so this is 3.1, just picking up from where we left off in the last video where it was part one. And if I remember correctly, in the first video, as in the part one of the exercises 3.1 that I was working on. Um, I think if I remember correctly, oh no, everything was fine in that code. I think I can't remember. It's been a while. I basically took like 5 or a week or 7 days off from doing these videos. Um, I enjoy doing this, but it's just sometimes when you keep doing it every day and stuff like that, it gets a little bit tiresome. But um, I'm going to keep doing videos like this anyways because you need to keep using, your skills and stuff like that so you remember and you have to try different ways to learn new things, right? But anyways, yeah, I'll just go ahead and go over this class here for the exercise 3.1. So it's in the package, the My Complex class package that I created here. It has the two classes. The main program is here. And again, the main program, it starts off with the main method, right? Public static void main. This is where the main program starts. And that's what you want to do. You want to create your instances separated from the main program. If you're coding uh, like if you're using object-oriented programming, um, how can I say it? Uh, Object-oriented programming concepts, right? Whatever you're doing is based off of object-oriented programming, right? Um, so yeah, here we're at exercise 3.1, right? And we can see here, I'm looking at the website right now. We have a UML class diagram, and that's one thing that people need to understand um, before they start working on this website. You need to know the UML class diagram for Java, at least, so you can read these uh, class UML class diagrams basically and understand what they're asking for. Um, this is something that I remember when I was in computer science, in my computer science courses in college. They this is one of the things that we had to learn is the UML class diagram. Um, because in the workplace, there may be some workplaces where they will actually ask for, expect you to know UML class diagrams and have programs that they want to be done. In which case, they'll ask you to read the UML class diagrams that they create. And it's also good for when you want to develop stuff like your own programs and stuff like that. You would start off with a UML class diagram and map out exactly what you want. So for this exercise, the MyComplex class, we have a class called MyComplex right at the top here in bold. That's the name of the class. So if you look at the program, we can see here it's called mycomplex.java. And then we have two private access modifiers, right? The access modifiers are at the beginning, before the variables and before the methods. You see the minus. Minus means private. It means that nothing can access these um, the values stored in these variables outside of the class itself. And that's one of the things. That's one of the reasons why we use um, object-oriented programming is for data hiding. So that's the purpose of it, is to hide the data that we're working with. Um, and again, these are called access modifiers. And um, there's like, I think, four different types of access modifiers, if I remember correctly. The plus here that you can see before all these methods here, they all have a plus sign to begin with. That's it's a public access modifier, so anything can access the data outside of the class, outside of the package, anywhere, any anything. Sorry, anything can access these methods, right? Um, and then um, you have the we can even just go ahead and search right now. Java access modifiers. There's the package access modifier, and then there's the other one. Let's see here. I don't really like that website. This one's good. Geek for Geeks is a good website if you want to find good and accurate information on programming, at least from my own experience. So yeah, we have default, which you don't provide any keyword for the access modifier, and if I remember correctly, the default is similar to public. But anyways, then we have private and we have protected. Um, you can see here, just one second, let me close that. So default is basically same. So the class that the variable was created in, or the method or whatever, that has an access modifier, whichever class it's created in, that anything from inside that class can access the value stored in that uh, variable or method or whatever. Same thing within the same package subclass. So if the access modifier is default and in a certain class inside of a package with another class, in which case the other class is in the same package and it's a subclass of the uh, superclass that has the default access modifier, it can access the value stored inside of the methods or inside of the variables that are default default access modifiers. Same thing with the non-package subclass, um, but with the default you cannot access um, the data or the values inside of the met variables or methods that have access default access modifiers. that are outside of the class, outside of the package of whichever class is created within. Um, and yeah, so, 1 second. Oh, yeah, we were here. Okay, sorry. I took I paused the video, but um, yeah, you can even read it here, right? I guess I'll link it in the video description. But basically, it's accessible by anything that's inside the same package as and the same class that is declared within, and within the same package that the class where the method or the attribute slash variable was declared within the class, as long as it's in the same class and it's within the same package, and it's, yeah, doesn't even need to be a subclass. Um, the subclass doesn't even yeah, it doesn't even need to be a subclass that can access a method or a variable within a different class, as long as it's within the same package. And if it's outside of the package, then nothing can access it if it's a default access modifier. And then just private, same class, and then everything else is not. And then protected is everything within the same package, I would say, if I remember correctly. And then it's also uh, and also different package subclass. So if it's a subclass but it's in a different package, then it can access the protected method or variable. And public is pretty much everything. I thought there was another one though, but I guess not. So yeah. Now let's go back to the program and explain what's going on here. So we have two instance variables, real of type double. So the data type is double. It's a primitive data type, and if we can go ahead and explain primitive and reference type. Uh, Primitive versus reference types. Geeks for Geeks. Geeks for Geeks is a good website. You guys should use that one, in my opinion. Or just use whatever you want. It's a good website, in my experience. Um, Java is statically typed, and is also a strongly typed language, because in Java each type of data, such as integer, character, hexadecimal, pack, decimal, and so forth, it's predefined as part of the programming language, and all constants or variables defined for a given program must be described with one of the data types. So unlike Python, where the type is assumed based on the data that you're storing within the variable. And if I remember correctly, in Java 10 and up, in Java version 10 and up, there's a data type called var, and it's I guess it's similar in a way to how Python's data types work, in which case you don't have to statically type the data type. It's just assumed, right, based on the data you're storing. In Java, there's a type var in Java 10 and up, where you have to declare var as the data type, but it will automatically assume the data type, which is kind of funny that you would have to declare it, but it's like this. So var this thing is equal to 0.0, 0.09.0, whatever. This doesn't really matter. Um, it's going to tell me that the version that I'm compiling with or whatever is not Java 10, and it's going to ask me to switch it. Change workspace compliance and JRE to 10. So, like I said, it's in version 10 and up, but you can basically use var to just automatically detect the data Um, I mean, automatically set the data type based on the values that are being passed. So I'm guessing that basically with this, you can just like pass different data types and it changes um accordingly, right? So this would set the data type, I guess, to double or float. Not sure. Probably double. I haven't used var at all, but I saw somebody use it before, and I had to go and figure out what the heck it was because I never used var in Java. I didn't know that you could have a non-statically typed data type. Um, so in Java, there's the data types in Java are of different sizes and values that can be stored in the variable that is made as per convenience and circumstances to cover up all test cases. So basically, with Java, um, it's important to know to choose the right data type because um, you might have there's multiple different data types that you can use that store the same data type or data. Like I think if I remember correctly, right? Like you can see right here, data types in Java. There's integers, there's byte, short, int, and long. And the reason why you would want to use these different ones for integers is because eventually, if you want to be the best, kind of software developer or programmer or whatever, you would want to know, you would want to save the most memory. And when you declare a data type, certain data types, such as long, if I remember correctly, will create a new space in the memory where it's a larger space than, for example, a short integer. Um, it's taking up more space. If I remember, if this, don't take my word for this 100% because um, I haven't worked too much with these different types, but eventually I will. And uh, yeah, you would want to use them when you know that you don't have to store something of a large size. Like for integers, you're storing numbers, right? Whole numbers with no numbers after the decimal point. So if you know that the kind of values that are going to be stored in the variable or whatever, you want to you you want to choose the right data type accordingly, right? So if you know that you're going to store a really, 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 really long whole number, you would choose long, right? Or in between short and long, you would choose int, if I remember correctly, and then you would choose short for like if you know that the types of data that's going to be stored in that variable is going to be uh, just a very small number, whole number, right? So like if you're just going to store somebody's age, right? And you know there's only 3 digits maximum for a person's age as of this video, right? Who knows in the future? Maybe we'll live until a million. Um, I know that's ridiculous, but who knows, right? We could live forever. Who knows? But eventually. Um, but you would want to choose something like short. I think I can't remember how much um, can be stored in a byte. I think it's just like 1 digit, maybe. I'm not sure, but I know for char character, which is basically anything, it's just one character. So yeah. Anyways, that's all I'm trying to say. And we have it says Java has two categories in which data types are segregated. Primitive data types, such as Boolean, char, int, short, byte, long, float, double, and then non-primitive data type or object data types, such as string, array, etc. And Hmm. Primitive data types. Primitive data types are only single values and have no special capabilities. There are eight primitive data types. They are depicted below in tabular format below as follows. So byte stores numbers from -127 to 127. So if you know that you're going to have numbers, these numbers and in between, then you would choose a byte to store the numbers. So this would probably be a good type to choose for if you're storing somebody's age, because we don't really have, I don't think there's any record of anybody. Let me see. Longest living human age. 122. Oh my God. Well, there you have it. So yeah, this would be a good data type if you're storing whole numbers for an age example, because the longest recorded human age is 122. So this would be a good one for that. And then we have char, which stores characters representation of ASCII values 0 to 255. So any kind of character, like, I don't know, like this character here, or a comma, or a parentheses, or a minus, or a plus, or a or a B, or a C, or a 1, or whatever. It stores one. It stores one single character, I think, if I remember correctly. Um, and you can see the size here. This one byte only takes 8 bits, right? So that's how much data it's taking. It's taking when it's creating a new space in the memory, I think, if I remember correctly. So yeah, and then you even have Boolean where it's only 1 bit, which is actually really nice. Then we have short, so a number like from there to there, and then int from there to there, and then long, which goes all the way up there. So one example of that I can think of that where like so basically there's this popular game, and if you guys go back in my videos, um, I'm not really gonna talk about it, but it's MapleStory, and they store um, data for like stats for like characters in the game, like like strength or intellect or luck or um, what's the other one? Dexterity. They store the values as short. I know that because the maximum stats that you can get for each of those particular stats is 37,767. That's the maximum stats that you can store for all of those values. And they did that because they thought that they would never have to increase the size, right? So that's just how it is now, and the way that they did it so that they can have more stats for the player is that they just had extra items, right? And then they gave those extra items their own stats that can somehow increase, Anyways, my point is that you would choose the data types, and these are primitive data types, based on what you would assume, what kind of data goes that would be stored in those variables, because you would also want to take into account the size, right? Because you're saving memory, and in programming, memory is everything. So yeah, so double. Yeah, okay, so I see double is okay. Anyways, and then let's see here. When do we get to the non-primitive data types? And if I remember correctly, the difference between, and don't take my word for this. We're about to read it and find out ourselves. But if I remember correctly, um, a non-primitive data type or object data type, I think it's also called a reference type. In which case, it's just a reference to something, right? it's almost like let's read it. Where is it? Non-primitive data types are reference data types. Yeah, so I was right. So it basically it's like it references a primitive data type kind of. Or like a reference type is kind of like it's a reference type if in my understanding, right? And this is just like me without because I don't even remember like anyways, reference data type is like so we have primitive data types, right? Well, a reference data type is like it references multiple primitive data types in different locations in the memory. That's kind of what a reference data type is. It's kind of like it references something that has multiple primitive data types, basically. So let's go ahead and verify if I was right or not. So the reference data types will contain a memory address of variable values because the reference data types won't store a variable value directly in memory. They are strings, objects, arrays, etc. So, yeah, like I said, like a class, right? An instance, like we create here, the myComplex class. It has multiple um, variables, right? Here we have two variables, two formal parameters of the constructor myComplex that we declare here that only exists within this method, right? And then we have two other variables here, and then we have multiple methods, right? Those are all, well, not all. So just the variables themselves are primitive data types, and then anything else pretty much like a method is pretty sure that it's kind of like a reference data type. It doesn't really mention it here. Yeah, it doesn't really mention it here, but like an array, right? An array is a storage of multiple different locations, aka indexes, right? In which case each of those index stores a primitive data type, like a double, right? Multiple double data types if you declare your array as a double. Um, and then you have a class which has methods that have variables there, and then it has variables itself. So that's what I'm trying to say. Like it's reference data types are like something that holds multiple primitive data types. An object, well, an object is practically the same thing as a class, except, well, in some instances, right? Like the myComplex class is obviously it's an instance or an object versus the myComplex app, which is just a program to run and test everything, right? Um, in which case, again, an instance or an object, which is the same thing, um, they have multiple primitive data types usually within them, right? Otherwise, how are you supposed to store any information? Same thing with an interface. Interface is the same thing. It's just another class that holds multiple primitive data types, and so is an array. An array it holds multiple different primitive data types. Um, and then strings, though, strings is a little odd to me. Strings are defined as an array of characters. Okay, so there you go. Strings are an array of characters. So strings is kind of like an array of what is it? An array of characters, like I said, right? An array of characters. That's what a string is. It's an array. So if you create a string call, and within the string you store a string call that's, let's say, here's an example. So string this thing equals, and here's a string, this. The string, this things, is an array of characters, in which case each character is stored in a different index, such as t stored in the 0th index of this thing's string array, and an h, and an I, and an s. So that's the point, right? It's that's what you need to understand, I guess, if I'm not wrong. Reference data types is what I like to use because that's pretty much what it is when we describe these, because they're referencing multiple different primitive data types, right? Via one name, right? So the myComplex instance, when we create an instance of myComplex, right? For example, here uh, we have, okay, we didn't create an instance yet, but let's just say I create an instance of myComplex, right? So myComplex C1 is equal to new. Remember, the new keyword, basically, the new keyword, it means that you're creating a new um, location in the memory so that you can, for the data to be stored in, right? So new myComplex, if I remember correctly. Um, so here we have a new instance of myComplex called C1, right? And what was I trying to get to again? Kind of forgot. Um, I can't remember. Anyways, I think you guys get the point. I think you guys get the point. Um, so now I'll just go ahead and explain the rest of the program here and the UML class diagram here. So we have two instance variables, both of type double, so you can just have them both on declare the type and the data type and the access modifier, and then just create both of the variables and separate them using commas instead of writing it like this. But this is preferred. This is actually preferred to be written like this because it's more readable. I think that's why it's more preferred. Um, but uh, just to make it faster, right? Because I'm not trying to take into account all the memory that I'm using and stuff like that right now. I'm just going through these exercises to refresh my memory and to help other people, I guess. Um, but yeah, so we have both of these instance variables of both of data type double, and they're both private, denoted by the minus signs, and then equal to, and they're instantiated or put into existence. I think that's what instantiated means. It means that they're brought into existence. That means that we're creating a location in the memory, and we're storing data inside of them, so now they exist, right? They're being stored with these values of type double. Obviously 0.0 is what it says you need to do right here. And as here we have, when you see a class name and then you see a method that's exactly the class name, that's the constructor. Constructor is used to create an instance with specific data, I guess, to pass, to create an instance and pass data to the instance, I guess. So we have a non. Some people like to call these no argument constructors. I like to call it a non-parameterized constructor. Basically, there's no parameters, right? So that's just when you create an instance, that's you don't have to pass any arguments, like I did earlier. This would be an instance that calls the non-parameterized constructor of the class because there's no arguments being passed. If I want to call this constructor, I would pass two arguments of type double because the parameter takes two doubles, right? So if I want to instead create a new instance and I wanted to pass two arguments as doubles for the instance to get, I would pass two doubles, right? 2.2 and 2.5. And so a new instance of my complex is created, in which case two values are passed as arguments to the formal parameters. And then, so that's the parameterized constructor here, which has two formal parameters, real and image, imaginary, of type double. And if you guys don't know why we're using a real and imaginary number, it's because we're working with complex numbers, and complex numbers, just to put it simply, is a number that's imaginary, a real number and an imaginary number added together. So here's an example. 3 plus, I don't know, 7i. So let me just comment this out. I'm just going to comment it out so there's no error. But you can see here 3. So just ignore these things right here to comment out anything in between them so it doesn't get run by the program, so it's not going to throw any errors. But we have a complex number, and a complex number consists of whatever real number you want. So it could be 3, it could be 35, it could be 78. And then on the right, it's an imaginary number. And an imaginary number always has an I next to it. And technically every number is, and we call this combination is called a complex number. So if I come here and I do, this is a complex number. Below is a complex number. So this is a complex number, right? Because there's a real number and there's an imaginary number. And technically every number is a complex number. So 7 is a complex number. It's because we don't see it, but it's plus 0i. It's just we don't see it. It's there, but we don't see it because we don't have to write it, right? Because technically it's equal to 0. Because what you guys need to know is that I is equal to the square root of 1, negative 1. And if you guys know, the square root of any negative number, it throws an error, or in Java at least, running through Eclipse, it'll throw, it'll show an error when you run the code where you're basically square rooting a negative number. It'll put output through the console nan, which stands for, so nan as in like this. This will be right here, NaN, will output through the console, and that basically means not a number. Not a number. It means it's just not a number. It's not, So it doesn't exist. It's imaginary, basically. I'm guessing is what they mean. So you could basically say it's imaginary. And that's technically what it is. Because the square root of negative 1 is I, which is imaginary number, right? And it doesn't matter what you multiply by I, it's always going to be an imaginary number. So enough confusing you guys. You guys could look that up yourself. I just wanted to explain what we're working with here. They're saying a my complex class. My complex we're talking about a complex number, right? You can see here, uh, math is fun. This is the website that I use and I like it. You guys I'll post the link in the description for all of these, the access modifiers, the data types, and the complex numbers. But this website goes through what a real and imaginary number is, what a complex number is, which is a real and an imaginary number added together. And you can see here, I is equal to the square root of -1. And either part can be 0, and it's still a complex number. So the real number can be 3, 5, or 0. Imaginary can be -6, 0, or 2, whatever. It's still an imaginary number. And this is a formula for adding imaginary numbers, which is what we did in this program. So if we go back and I stop confusing you guys and going kind of a little off of what I'm trying to do here. So then we have getter and setter functions. And what you guys need to understand is that this, when we're working with object-oriented programming, you want to have getter and setter functions, because that's how you get the data, or you set the data for the private instance variables or whatever variables that are private. So remember what I was saying, the access modifier limits the scope, I guess, of the variable, which means that when you look through, for example, right, a sniper scope, you're playing a game, right, a gun game, and you're looking through a sniper scope, right? The scope is a small view of the world, right? You can't see the outside of the scope, right? So you're only seeing a certain part of the world. But if you look out of the scope, right, and you're looking through your eyes, you can see a wider field of view, right? So the scope, so that's what the access modifiers do. They limit the scope of the variable. Only certain things can see it, right? And for example, private, only the class in which the variable was declared with an access modifier private can see its data. So only this class can see the data, but can see the data inside of this variable, right? My complex app, which is another class, it can't see the data stored inside of real. It can see that there's a real variable, but it can't see what's inside. It can't change it, and it can't see it. And that's one of the reasons why we use data object-oriented programming, is to hide the data. It's called data hiding. Now, that's why we have getter and setter methods, because the getter returns the instance and the value stored inside of that instance's real location, right? The data that's there, the value. And in the setter function, it just sets the value, right? So that's what we're getting to now. So we have the get real method, which gets, you can name it whatever you want. Obviously, that's. I mean, I'm sure you guys already know that by now. We have the public access modifier, and it's of type double, the method. So that means that the method has to return something of type double. And real is of type double. We can see here it's of type double. We declared that. So it must return something of type double. And public void, void means that it will not return anything. So you use void when you're not returning anything. And here, that's what we're doing. We're using, almost always you'll see when people declare or create setter methods, they it's always of data type void. That's primitive data type, I think. I think. Um, and then here it's taking a formal parameter of type double, data type double, primitive data type, remember, called real, and then we're setting the value of the instance that called this method, its real attribute, we're setting it to equal the value that's passed to, as an argument from whichever instance calls this method. So an example would be over here we created the instance of my class, my complex called C1, right? So if we go here, we go C1.set real. Here it takes an argument of type double. So 2.2, that means that 2.2 is being passed, right, as real, as a double data type is of type double. And this just means that we're talking about this instance, right? And it differentiates the real of this instance between the real of the formal parameter. That's why we use the keyword key. Um, okay, so anyways, and then we have get. Okay, I need to hydrate. 1 second. Okay, sorry. And it's the same thing with the get imaginary and set imaginary methods. Same thing with set. Okay, so back to what I was saying. Set value. Here they just want to set the value for real and image imaginary. So we're just doing what we're doing here for set imaginary and set real, just in one method. That's the only difference. And then the user is passing two arguments towards these formal parameters. Then we have a toString method. And what everybody needs to understand is that Java, by default, in its string, string class, the string class for Java, which everybody needs to understand this other thing as well. So every primitive data type, if I remember correctly, they have their own class, which is named the primitive data type. So if I remember correctly, so string, double, integer, all those have their own class, and it's called string, double, integer, and stuff like that. So they have their own class called the name of the data type. And then the string data type, its class has a toString method, which returns a string representation of the object. If I remember correctly, it returns something like the memory address location and the data type. I can't remember, but when you want to format the output, when you call, for example, when you want to print out an instance, aka an object, if you want to print out something specific, then you can format the string, and you can, well, you override. It's called method overriding, is when you override a method of the same name. Um, in which case, you can basically modify what happens when the toString method is called, right? And here we have to return a data type string, so we're returning a formatted string, such that we're using format specifiers. %f and %f here are format specifiers, and what's going into the format specifiers is the values of these attributes of the instance that calls this method. Then we have the public boolean is real, so we return true or false. Boolean is true or false. That's the data. That's what has to be returned. And then we go through an if-else condition to check if imaginary is equal to 0, and we return true. Otherwise, we return false. That's the request that they ask for here. For the isReal method, right here they say isReal. Here you can follow. Return true if imaginary is 0. And then we have the toString method here. This is what they wanted. They wanted us to format it like this. We did that. So they wanted the real and the imaginary values, and then a plus symbol in between as a string. You can see about the double quotation marks. It means a string. Example here, 3.1 plus 4.05i, and we add the I at the end because it's just to denote that it's an imaginary number. It doesn't actually do anything. Um, no formatting for double, so format we don't specify how many numbers after the decimal point that we want. It can just be whatever we want. So for example, if you wanted it to be formatted, I think it's like this, 0.02 after the percent sign, and then F, it means that we're formatting a float or a double, in which case only two numbers after the decimal place will show, or we can change it to 3. It would be 3 numbers at the decimal place, but they don't want any formatting like that. I think that's what they mean by no formatting for double. And then we have the is imaginary, which is the same thing as is real. They're checking for the real and the imaginary number. And then here we have method overloading. It's when we have multiple of the same method names within the same class, um, which is possible, as you can see. When you do method overloading, it's like I said, it's the same method name, but we're creating multiple methods with the same method name. The only difference is that we have different formal parameters, right? So here we have two doubles. Here we have one instance of my complex, and um, yeah. So so whichever whatever's calling this method, which is more than likely always going to be an instance, the program will know which equals we're talking about based on the arguments that are passed, right? So for example, here we have the C1 instance, which will use the equals here. And here, if we pass an object, so we can pass C1 itself again, or if we wanted to, we can create a new instance called C2, right? We can pass C1, there's no issue with that, or we can pass C2. As long as it's an instance, that means that the program will know that we're calling this equals method because this one takes an instance of my complex, which we're just calling another, which is just like any other variable. We give the name, right? This is just a name. It can be whatever we want, but this is the type. The type is of class or instance, actually, of instance of my complex. And what we're doing here in this equals method is we're checking if the real of the instance that calls this method, so C1 is calling equals, right? C1 is an instance. It's calling this equals method, and we're comparing the instance that's calling this method. This means that it's the instance that's calling the method, right? We're comparing its real attribute to the other instance that we're passing here, or here, C2. We're comparing their real instances, real attribute values to one another. We're comparing them, right? Is one equal to the other? The equal operand. We call these operands, right? And or is on and an operand? Anyways, equal or plus or minus. Those are operands. Um, Basically, we're comparing to see if this is equal to this. If it's true, then it'll return true. But actually, um, whatever is um, happens in this whole bracket, in this whole parentheses, is what will return. So if this is equal to this, and the condition has to be that both of these need to be equal to each other to return true. But if this and this is equal, then that's true, okay. But if this and this is not equal, then it'll return false. Um, so that's what method overloading is. So if instead we passed two double values, 2.4 and 2.7, it would know that we're calling this equals method because it takes two arguments as double values, and these again are called formal parameters. Well, this is a variable, but it's a formal parameter or a parameter. Some people like to just say parameter. There's also, you can call it formal parameter. I think there's different kinds. I can't remember. But yeah, this formal parameter is just an instance, and then we have another method called magnitude that they wanted. Um, and the magnitude of a complex number is the real value multiplied by itself plus the imaginary value multiplied by itself, and then square rooted. And we use the square root function from the math library. This is a function from the math library. Square root is a function from the math library. So just like we have the myComplex class and we have the equals method, we have the math class, and then we have the square root method of the math class, which is by default part of the Java library. Have I been saying Python? I keep forgetting. We're in Java. When I first started this channel, we were doing stuff in Python. Later on, we're going to be moving, or at least I'm going to be moving to C++, C after this. I've already worked with C before. We'll get into that in another video, but I want to try to finish all these exercises first. I'm not sure though. And then we have the add into method, and here they want us to add write into this instance and return this instance. So write is an instance of myComplex, and they want us to add its value to the value of. It wants us to add the attributes of the instance that's passed as an argument to the attributes of the instance that calls the method, and we must return a type. We must return an instance of myComplex, right? So we return a new instance of myComplex because that's what they want for the add new method. But for the add into, we're basically public is the access modifier, and then we have the data type, data type reference, right? A reference data type. Remember we just looked into that. Reference data type just means that it refers to multiple primitive data, right? Primitive data types, and myComplex does have multiple primitive data types. You can see here there's already two here, two double primitive data types. And then we have the method name add into, and then here the parameter or formal parameter is named write, and it can be named whatever you want, and it's of type instance of myComplex as well. And since the data type is of type instance of myComplex, we must return an instance of myComplex, which we do. We return this, which is the instance that calls this method. And here what we're doing is we're storing the attribute, the two attributes that are the instance that's passed as an argument to this method. Right, we're adding its two attributes, real and imaginary, because remember every instance of this class has a real and imaginary instance variable and value. You can see here. when we create an instance, it gets these two values and they're set to 0. We're adding them to the instance that calls this method, and then we're setting them to go here. We're setting them to as the values, whatever this equals, we're setting it as a value to the instance I call this method, its attributes. We could also do, I think it's like this, plus equal, like this. It's the same thing. It means that we're adding this, and then we're storing it here, back here. It's the same thing. Or you could just do this, it's more readable. Then we're just returning the instance I call this method, and here we have this another method of type instance of my complex, and we're also passing another instance of my complex as an argument to this parameter of this method. And here what we're doing is we're creating a new, that's why it's called add new. It says right here on the website, it says add this and write and return a new instance containing the sum. So that means that we add these two. So we have the instance calling the method, and we have the instance that's being passed as an argument. We're adding those two together. They're attributes of the same attributes together. So the real number and an imaginary number, we're adding them together, and we're storing them to a temporary memory location, which we call new instance real of type double. And we're storing it there while we're in the method, and then we're creating a new. Remember, new creates a new memory location for the instance of my complex, in which case we're passing these arguments as the values for the new instance of my complex. Remember, we have this parameterized constructor that takes two double values when we create a new instance of my complex. That's what's happening here. We're passing these two arguments, the values of these, as the double values for the constructor of this class. And that's pretty much it. What else do I want to talk about? Oh, yeah. So that's pretty much going to be it for this video. Um, because in the last video there's no audio, so while I was explaining everything, it just wasn't recording, right? And I already explained everything that happened for like the last 60 videos. I explained at the beginning of this video and my last video that I posted on my channel about why there's no audio. You guys can check it out if you're interested. It was just a mistake on my part. Just like I didn't realize. But basically what's happening here is we're already done writing this class. This is all finished. Now we're writing the main program where they want us to, you are required to write the my complex. Okay. Here they want us to write an application called my complex app that uses the my complex class. The application shall prompt the user for two complex numbers, print their values, check for real and imaginary and equality using the methods that we created, and carry out all the arithmetic operations. So that's what we're doing here. We're writing a menu, and I'll explain the menu in the next video because, well, it's not finished, and we're going to finish it in the next video, which should be the last video. So yeah, that's about it, and see you guys in the next video. Next video, again, we're going to be finishing this main program, and then I want to go to the next exercise after that. Thanks for watching. See you next video.